Please welcome Zoltán Lehoczky, Managing Director of Logic Technologies, who will share insights with us. Your code is already on GitHub, so why not automate everything with GitHub Actions too? We will see how you can use GitHub Actions to run or check code builds and execute tests, link everything, run spell checking, manage an Azure environment, and help contributors.
Yep, hello everyone. I'm not sure why I'm the second speaker actually. I didn't do the program. Because it will be an interesting talk, but it will be a useful one, alright? Because it will be about automation and ready to use automation. So just a little bit of interaction if we haven't yet met. I'm one of the co-founders and managing directors of Lombik. We do a lot of stuff with Ocean Core. Here are my socials if you want to stay in touch, but I will show them a little bit later as well, because we have important stuff to do. GitHub Actions. Is there anybody who hasn't heard about GitHub Actions yet? It's no shame. Everybody. Awesome. Then just for the people watching back at home, GitHub Actions is a virtual automation tool usually used for CI/CD tasks. It's built into GitHub, you can just use it there, and it's also integrated with GitHub, which is important because, for example, it has all the context of a pull request there. It's integrated with GitHub also with the events, what I will also touch on, like when you push something, open a pull request, add a comment. That's also something that GitHub Actions can integrate with. When you create GitHub Actions workflows, then you are writing YAML. So that's maybe not the best kind of code that we as developers can think of, but it's useful and it works. And you can use it to, for example, run builds, run tests, execute static code analysis and linters, all of which I will show you. Also do some spell checking. I will talk about that even, deployments, or even update dependencies. And spoiler alert, I won't talk about that today, I will talk about that tomorrow. And of course, Ocean Core uses GitHub Actions as well. So, since everybody here knows GitHub Actions, let's write some GitHub Actions code from the absolute scratch. No, I'm just joking. Of course, this is not a GitHub Actions tutorial. We will see something that's ready to be used right now without too much coding, but you can also write some code if you like. So let's instead just go ahead and automate stuff. The project I will use today is one of our open source projects called Lombik GitHub Actions, and you may have a guess what it's about. It contains a lot of reusable GitHub Actions workflows and also actions. If you are maybe not familiar with that term, actions in GitHub Actions terms are basically like libraries, probably you could think of them, or bigger than classes in C# terms. These are reusable pieces, but the small pieces are called actions and the bigger pieces are called workflows. You can use both of those. You can use the workflows if you just want to plug and play, and you can use actions if you want to be more granular. So, we'll go through a couple of workflows here, and I will show you each of them and tell you why they are useful and what you do with them. The first one will be what we call build and test Ocean Core, which is about building an Ocean Core solution and running tests on it. This is probably the most important one, so that's something that every project needs. If not with this one, somehow. What it does, apart from just what I told, is that it also prepares the environment. Specifically, it sets up .NET and Node.js, and it does this for very specific versions. This is very important. If you have a build, you want it to be repeatable and reliable. One of the key things that make that possible is having all the dependencies, all the environmental dependencies being pinned to a specific patch version. I'm really talking about specific versions here. For example, from .NET, we have something like 8.10 or 8.0.10 300 or whatever configured. The reason for that is because even patch versions can bring changes that break your build. They might be very useful, but still they can break your build. For example, there's a fix to Roslyn, and that makes some static code analyzers work better, and now you have new analyzer warnings, which will break your build. We started with more forgiving version selection here, but we figured that really usually you want to be very specific there. And then you can decide to manually change that version number if you are ready. By the way, these workflows also set up SQL Server, Elasticsearch, and Azure for UI testing, for tests that actually run the application and click through it. And with this, we have all the dependencies there. So let's actually see it in action. First, here's that Lombe GitHub Actions project that I mentioned. I will also show you the link to it. It's of course documented, and probably I will get my mouse back. If not, no problem. There's documentation about both the reusable workflows and the actions that I mentioned there. And here's an example of that working. Unlike my mouse. So this is an example of a smaller project running those builds. Here on GitHub Actions, you can see the build. All the builds listed here on the right-hand side of the screen. You can only see two because I recently renamed this workflow in this project, so there weren't many builds. And if I can open it. Sorry, the touchpad here is broken, so I will need to quickly fetch my mouse from my bag. You notice with live demos, it's always something breaks, but something breaks in a way that you don't anticipate. Like the touchpad never broke on my laptop before, but it broke just now. And unfortunately, I do need a mouse here. Although part of an important area called accessibility is that your software should work without a mouse as well, just with keyboard navigation. And I'm sure that GitHub works, but I'm just not that versed with it. So now that I have a mouse, I can actually open a build here. And this is how it looks like once it's finished. Everything is green here, so this was a good job by whoever did it. It was actually me. And here you can, for example, see a test report. So all of your unit tests, in this case these are just unit tests. You can see the details from them here, all of them passed, so great. If we scroll down a little bit, we can also see some metrics. So this Gantt chart-like chart here is about having a timeline of all the steps in your workflow. This is useful to have a quick glimpse of what your workflow does. So if it's too slow, and it's always too slow, if it's too slow, you will be able to see what's actually slow. Well, a helicopter view of that at least. And if you scroll down a little bit, you will also see a hint on why it might be slow, because this is the CPU metrics chart. So it's relatively low. This is a simple workflow. It's relatively low, so that's good. You want to have it consistently around probably 70–80%, because that means that you are using the hardware, but you are not oversaturating it. We also have some memory metrics here. Green means free, so almost none of it is used actually on this machine. That's good. And some IO metrics as well. But even more important here, or interesting, is the workflow log here. So here, all of these lines you see here are the workflow steps. So what does it do? It does a lot of things, but the important ones are it checks out the repository, because we need the code. Then it sets up .NET, so that's what I mentioned. it also sets up nodes, just as I mentioned. And by the way, in between there's also something called .NET verification, .NET consolidation verification. Now, if you are using NuGet packages or the same NuGet package in multiple projects of your solution, the general wisdom is that it should be the same version, because that means that you can work with it more easily. This step checks that. It's optional one, but I think it's useful. It checks that, okay, if you are using Orchard core whatever in project A and it's on 2.0.0, then in project B it should also be on 2.0.0, or perhaps you should upgrade to 2.2.1. Then there's the build and static code analysis step, which does exactly that. It's not setting up SQL Server, Elasticsearch, and Azure this time, because this is a simpler workflow. We don't need that. Then it runs the tests and then some cleanup. If we check out a more complex workflow in our so-called open source Orchard Core Extensions project, you will see that it actually has multiple jobs. Now, jobs in GitHub Actions terminology are like workflows within workflows. They run in parallel. So in this case, we actually have two build and test jobs, because we have two solutions in this repository. One is testing different things than the other, that's why. And one important thing here that I didn't show you in the previous one, an important step, is this cancel workflow on failure. This means that if one of the jobs fails, then the whole workflow will be halted. This is to consume resources. So if we have two builds here, if one of the builds fails, then that means that you messed up something. There's no point in continuing the rest of the workflow. This is about that. This is not a built-in GitHub Actions feature for some reason, so you have to work a little bit to get that. And there are other jobs here, as you can see on the left side. I will talk about them a little bit later. And this is how the code actually looks like. In the first workflow that I've shown you, the simple one, it's just this. This is all the code. First, we have some triggers here, as usual. I recommend you use the triggers pull request, which means if you open a pull request and if you push commits to that pull request, then this will run. And I also recommend you to run it on pushes, in this case to the dev branch, which is our main development branch. And then we have a single job here, since this is a simple workflow, which pretty much the only necessary thing you need to have here is this line here, which references that reusable workflow in the Lobby GitHub Actions project. Again, this uses the workflow. This uses the workflow, but you can use the actions as well. You can have your own workflow, your steps listed there, and then use the granular actions if you want to go lower level. The more complex workflow that I've shown you in the second case is here. You can see, for example, it uses more configuration. This is all documented. I won't go into detail. It also, but by the way, it sets up SQL Server and Azure because it has unit tests that run the application. And it has other jobs here as well. So all these other lines that you have seen on the left-hand side, even spell checking with something called code spell, are these jobs. Something else, I think the second most important thing is publishing NuGet packages, because you all publish Orchard Core related open source projects, right? And you need NuGet publishing for that, because of course that's how you can share it with others for them to actually include them in their applications. Orchard Core modules and themes should be packaged and published up as NuGet packages, and for that you can do that manually, but I recommend to make it automatic, for which GitHub Actions, of course, is a usable thing. And this reusable workflow that we have here called publish NuGet package, it does exactly that. It builds a solution, and the .NET solution and .NET project. Again, it sets up Node.js and .NET, so it's reliable. And usually, this is something that you trigger with a git tag. So you add a tag like v1.0.0, and then it will run this workflow and do everything automatically. So let's see how it looks like in action. This is from the example of our helpful extensions module, which is very helpful, as the name suggests. And you can see in this list all the releases we had. All of these are alpha ones, so not that important, but actually here, if you scroll down a little bit, here we have v11.0.0, so that was the last public release. And if you check out this workflow run, it's green, so that's good. Within the workflow, there's not much interesting actually. Again, it checks out the code. Again, there's .NET and Node.js set up. But this time, not just a build, but published to NuGet and some cleanup. But if you go back to the summary of the workflow run, there's one additional thing, an artifact. Now, an artifact in GitHub Actions terms is pretty much a file that your workflow can produce, and then you can download from the workflow summary. We figured that it's useful to have the NuGet package downloadable here as well, in case you want to check it for issues or archive it differently or something like that. One thing that's not apparent from here is that it actually also published a release on GitHub. So also very important. If you are publishing your project on GitHub, please use releases. It's very useful. This is how we can see when was the last release of your project and what does it contain. GitHub can automatically generate such release notes, which is also useful, although it's even more useful if you add some explicit release notes, especially if there are breaking changes. Something that we didn't do here, but you should. So this is also something that was automatically triggered. They're pretty much related to a release. Everything is automated here. You just add the tag in Git, and the rest just runs. And probably the third most useful thing here is spell checking. So, software project having correct spelling is probably not the top of the priority, but I think it's still important. And if you have spelling errors, then that means that sloppiness kind of permeates the project, and sloppiness breeds more sloppiness. Having good spelling is not a huge effort. I would recommend also checking it, so you don't end up with typos being fixed all the time or typos being pointed out during manual reuse. And a very good project for that is called CodeSpell. Now, usually a spell checker works with a dictionary, and that dictionary contains the correct spelling of words. So the spell checker takes a look at your text, matches it against the dictionary, and if something is not in the dictionary, that means that there's a spelling error. That's the very basic part of it. But CodeSpell doesn't do that. It has a dictionary of misspellings, which at the first glance seems like, what? Why do you have a dictionary of misspellings? But with code, this is what actually works well. Because in code, we have a lot of abbreviations. We make up terminology for our project. There would be a lot of spelling errors if we were to use the traditional way. But with CodeSpell, there's a huge dictionary of common misspellings, which actually has a very good hit rate. It won't find everything, but it will also have very, very little false positives, a positive rate, and that's important. We actually used traditional spell checking before, and it was a nightmare to maintain. We had huge dictionaries with our own terminology. We just continuously have to maintain it. CodeSpell works a lot better. And this is how it looks like. Well, first of all, here's the project. Again, I recommend it. It's a great project. It's at the core, it's a CLI application. It has its documentation here. You can also run it locally with just the command CodeSpell. What I recommend you actually do if you want to automate it, do it the first time locally, fix all the spelling errors, and then integrate it with GitHub Actions. And this is how it looks like when you actually do that. And again, back to this open source Orchid Core extensions project of ours. with the multiple jobs you remember, and one of the jobs is code spell. There's nothing really interesting that you can see here because it's green, just a couple of steps, and that's it. But important that, again, we use this cancel workflow on failure step here. So if you have a spelling error, the whole workflow will fail, and only when you fix that, then we will run all the costly builds and tests and everything. That's not a philosophy that you have to follow and subscribe to. In our experience, this is useful because this costs money to run. So you don't want to do it if it's not actually useful and necessary. If we go check out the code related to this, I already briefly shown you, this is pretty much the line that you have to use. And by the way, in the same project, we have a second workflow called, this one, called build and test Windows, which runs all the stuff but under Windows. And now I recognize that I unfortunately forgot to show you the publish to the get code, which is here. It's very simple as well. The trigger is special because it's triggered based on a tag, but the actual workflow is just very little, just a line to call that reusable workflow, and one configuration necessary, the API key. So this is the key that you use to publish to NuGet.org, or not just NuGet.org actually. This works with every NuGet compatible repository, including Cloudsmith, that we also use. It's here. And linters. Now, linters are related to static code analysis, or static code analysis is linting, but linting is usually something smaller. Linting is about code formatting, checking code formatting, basic code correctness rules. Static code analysis, I think, usually means something a bit more involved, but still checking the code without running it, hence static. And these are also very useful automated QA tools because this cuts down a lot on manual review. And it's also deterministic and reliable, unlike AI review. So linters is kind of the first line of defense, I think, in code quality, apart from the build and compilation itself, of course. So, for example, you can take something like CSS and check it for basic correctness, basic formatting rules. We have a linter for that, and also for JavaScript, and also for Markdown, so you can actually lint your Markdown documentation. Also for YAML, so you can have a YAML workflow that checks itself. Now, if you have only a single workflow, that's probably not too useful, but if you have a lot of YAML workflows and actions, not just GitHub Actions, but with whatever, probably checking YAML for some rules is useful as well. And we also have the same thing for PowerShell, actually. Now you may ask, okay, that's a lot of kind of code, but what about C#, which is kind of the most important? Great question. We don't have C# linting because we have proper code analysis there with rows and analyzers, but that's part of the MS build process. That's not a separate workflow, that's just part of the build. And by the way, I'm talking about the green squiggly lines in Visual Studio. If you're wondering, or in any IDE, it's green squiggly lines in the .NET world. I very much recommend you lint or run a static code analysis through all of your code. Again, it's the first line of defense against bad code, apart from basic build. And this is how it looks like. Again, I'm going back to this workflow here. Actually, no, this other workflow. This is how Markdown linting looks like. Really nothing special. It's green, good. If it's red, you will see the errors here in the summary page. But thankfully, this was correct. Here's YAML linting, nothing special, just a simple workflow. And here we have linting for CSS, JavaScript, and Markdown actually again. This is a separate job within, again, that open source Orchid core extensions project. So this is also a job that runs in parallel, and this is also a job that fails the whole workflow if it fails. So if we have linting errors, then please check that out. You should only continue if you have the basics fixed. And from the code, this is how these look like. Markdown linting, very simple, basic triggers. Again, pull request and push, same as the build one. And actually running the linter is this. Single line of code. You might need some configuration there, which is possible. By the way, this uses a project called Markdown Lint behind the scenes. So all of these use some commonly used, dare I say, industry standard projects behind the scenes. YAML lint as well, and the YAML lint workflow is pretty much the same as the Markdown lint one. Single line of code executing that reusable workflow. And this uses a project called YAML lint. And finally, here's that project that links everything else, scripts and CSS, which is pretty much just this line of code. We are actually changing this slightly. This is now in a different project, but we make it easier. Mark, in his talk later today, I believe, will talk a little bit about our journey with static asset builds and how we started in a complex way, and now we cut down pretty much everything. But long story short, we currently only have, in new projects at least, currently only have linting. Not static assets build anymore. We make the local development story a lot easier. And a couple of workflows related to Azure. Who here is hosting their apps in Azure? Actually, most of the people. Okay, something useful for you here. For all the others, you can also do something similar. You can check out the details of these workflows because in the end, deployments can happen in the same way. We have a couple of workflows related to Azure for the hosting process that we do and we recommend. And that's actually with Azure App Services. That Azure App Services is very simple. You just deploy an application there and it runs. We do staged publishing, so we have production and the staging slot. The point being that staging is where we deploy. That's where we check out whether everything works in an environment that's close to the production one, and then we swap out the production. So people don't actually notice anything. The deploy to Azure App Service workflow does the deployment itself, so it builds the application and publishes the binaries to the app service. Reset Azure environment. Now this is about copying data from the production environment to the staging one. So the staging one, again, should be as close to the production one as possible, but it shouldn't use the same data as the production one, or the same database. That's the correct way to put it. But it should still work with the same kind of data, again, to make sure that nothing will break in production. Because in production you can have user-generated content. You can have a lot more content than what you work with locally and even what you use to run tests against. So it's always useful to have the production data, a copy of the production data for the final testing. And the Reset Azure environment workflow does that. It copies everything from the production app. And finally, swap Azure Web App Slots is where the magic happens. That's when you swap out the staging slot to production, and that's when people will see your new things. And this is how it looks like. What I'm showing you now is our Lombik Tenants core project, which is the project that runs all of our own websites at Lombik. So if you check out lombik.com or Orchard Dojo or .nest, those all run on this application. So this is how the sausage is made. I'm now showing you something behind the scenes. And you might have noticed that, okay, but we actually have two jobs here already. Great observation. We have a job to actually deploy the application, and we have this test staging app one. This is pretty much the same as the build and test one I've shown you before, but it runs tests against the staging application. It runs UI tests against the staging application. The idea being here that, okay, now we deploy to staging. We have almost the same data as in production. The environment is very similar to production. We should check out whether everything works. And it does that from a user's perspective. But the more important or more interesting workflow here is this swap Azure DevOps slots. As I mentioned, this is the one that swaps the staging slot with the production one. And as you may have noticed, this also has a test production app job this time. So this runs the same task that we have run for the staging app, but on the production one. You can think of these as checking whether the home page looks like it should, checking a couple of important pages, whether they have the content that they should, or even matching them against image screenshots. So doing visual verification testing. It also sends like contact forms. In case of .Nest, which is an Orchid Core SaaS, so you can create Orchid Core sites easily there. It checks whether you can register. It checks whether you can log in and create sites and delete them. So all the most important features of your application can be tested like this. And of course, if this fails, then that's an oh shit moment, because that means that you deployed something, and not just deployed, but also swapped out to production something that's badly breaking, that you didn't recognize during development, you didn't recognize during the normal CI builds and tests. The reviewer didn't recognize it, and then you deploy to staging, and it still worked there, but something broke in production. That's bad, but at least it's better than not knowing about it, or knowing about it hours or days even later. So very important, smoke testing. You can sleep better if all of these are green. Trust me about that. And by the way, you can also execute these tests periodically. So it's something that we do. These also run periodically without anything on the production apps. This is not about doing availability testing. So this is not about checking whether the application is still up. We have separate, simpler tests for that, that check the app like every minute, and we get alerts if the app is down. But these are for the more important, or the more complex checks rather. In the swap itself, if we check out the details, it does swap with Azure App Services. So most importantly, it logs into Azure. It uses the Azure CLI, by the way, runs the swap, and what's more interesting here is that it also adds tags and release annotations. So again, if you are looking at the Git repository, in the history you will see that, okay, this is the commit that's currently in production. This is the commit that went out to production last week. And same in application insights, you see these release annotations that, okay, this is when we deployed the code that generated all of these exceptions. And that's quite useful and makes all this debugging much easier, especially if you don't have an exact error. It's just that now the app feels slower, or certain people randomly can't do something, then at least you have a hint where you might find the issue. And those are the most important workflows. We have a couple more there. For example, there's a workflow that can mirror to repositories or just selected branches from those, which is useful, for example, if you have a fork of an open source repository. There's a button on GitHub that you can click. I think it's called like sync. No, it's not sync, but anyway, the feature is that you sync your fork with the original repository, but you have to run it manually. This mirror branches does that automatically. We use it for a lot of things there as well. There's one what we call post pull request checks automation. It's to run things after all the builds pass. For example, you can manage the pull request automatically. GitHub has a built-in feature for that, but this can be used in different scenarios. More importantly, it can transition Jira work items. One of the things our developers use all the time is adding a label on a pull request to tell it to put the Jira work item into the done state if all the checks pass. Saves on a couple of clicks and having to wait around for the CI builds to finish. There's also a validate submodule feature, and I have a hunch that in this room it's only the Lombik team who uses Git submodules. Anybody using Git submodules here? Apart from me? Actually a lot of people. What is wrong with you? No, great. GitHub modules are a useful feature. They're a bit clunky. That's why most people don't use it. They are basically like sub-repositories. You have your repository, and you can put repositories within it, and in your main repository you can tell which commit the sub-repositories are on. Part of the reason sub-modules are not used more, I think, because the terminology is messed up. I use the words repository and sub-repository. That would be logical, but they are actually called super project and sub-module. Like, what is this thing? But they are still very useful. It's useful for sharing code. Now you might ask, okay, but don't we have NuGet for that? And of course, yes. But if you have like common libraries in a team, in a company, which are used on multiple projects, I think it's better to use submodules because then you can contribute to those projects right there where they are used. It's not like silos where one team is working on project for customer A, one team is working on a project for customer B. Both of these use your common library, but there's a third team that actually develops that library. And then they are throwing information around. No, everybody can develop that library right there in the project with submodules. And this workflow makes sure that if you have kind of like a main collector project where all of these submodules are included, this workflow makes sure that you actually have a pull request for that submodule open there as well. This is useful if you do something like us, where we have like open source Orchid core extensions project, where all of the open source Orchid core related themes and modules and libraries are there, but we have a lot of consumer projects. And then when people actually in those consumer projects contribute to these submodules, we tell them that, okay, that's great, good job, but please also open a pull request in the central one because we want to keep that up to date. So, if you'd like to start with all of this, here are the two most important links. The project that I've shown you being used almost for everything here is this / GitHub Actions one. I didn't actually separately show you the partial analyzer step. Forgot about that. Sorry about that. It was one of the jobs under the big workflow, but that's in a separate repository. And that also uses a library called PS analyzers, which just make it possible to use easily from GitHub Actions. And that was it, I think. You can now just take these and add CI builds if you dare not to have one to your project, and all kinds of automations. Also go there and check out the code. You might not be able to use these directly because you have different processes, or you are not using GitHub Actions even, but something like Azure DevOps, which, why would you do that? But if you use that, or Bitbucket pipelines or whatever, still I believe you can take some inspiration from there. So yeah, thank you very much.
So now we have time for questions. Anyone? Sebastian?
Sorry, there was nothing about shapes.
Thanks for the presentation. So I have a question. So for the deployment to Azure, so I suppose you are using the classical app services. So
yep.
They are not container-based. So first question, do you plan to support also container-based app services? And why not the container apps also?
Yeah. Behind the scenes, by the way, I think even those app services are using containers. But yeah, from our standpoint, it's not using containers indeed. We just didn't find the need for that. I think if you are using app services, I don't think there's really much point in using it with containers. If you use containers, just use container instances. That's something that we also use. I didn't show any automation for that, but we do have, but it's a small part of our development process, so I didn't find that important. Azure App Services in itself, I think it's very straightforward. I don't think containers are necessary there.
Okay. My second question is that you run your UI test against the SQL Server database. But do you plan also to run it against other types of databases? Because you also support many kinds of databases.
Yeah, good question. And SQLite is also supported. That's not something that will need anything special, as I didn't mention that because that just runs. I experimented around to have the same thing for Object Core itself. And there I actually implemented some kind of support for Postgres and MariaDB as well. You can do it in a basic way at least. So all of these workflows are extensible. You can have a step where you install and launch a Postgres DB or a MariaDB. What wouldn't be included, and that's why we have SQL Server support specifically, is the ability to, first of all, run multiple instances of the application in parallel with multiple DBs, so they are running separate tests. And secondly, to be able to create snapshots. So one of the things these UI testing processes do is that usually when you test an application, you test it with the same starting point from after the same setup. So what we do is that the setup only runs once from a recipe. We take a snapshot of that with the database, and then all the tests use that snapshot to start the application. They don't run the setup again. Now that's something that you would lack by just adding a workflow step that starts a Postgres DB. The UI testing toolbox that we use for that is also extensible, so you could extend it with a snapshot and restore step. But that's really perhaps complicated. We didn't look into that part yet. We didn't need it.
Thank you.
Other questions?
Thank you for a great talk. I want to ask, do you also use GitHub hooks or only GitHub Actions for linting?
GitHub hooks for linting?
Git hooks, sorry.
Sorry, I don't know about that. Or do you mean webhooks? I'm sorry,
No.
I don't get the question.
Git allows you to book some action. For example, when you commit, it can lint your code locally on your PC before.
Okay. So Git hooks.
Yes.
Oh, okay. Yeah.
That's what he said.
Yeah. Okay. But it's like when French people hear you try to talk French, and they play that they don't understand you. I did the same thing. Yeah. Sorry, I was in the mindset of GitHub and GitHub Actions having webhooks or something like that. We don't do that, but that's indeed something that you could do if your process is very fast, or you want kind of everyone to still run it locally as well before they even push it. We want to keep the development environment as simple as possible. So I briefly mentioned that for static assets we don't have builds anymore in our new projects. We just use the linters or render linters in GitHub Actions. And a big reason for that is that you don't have to do anything locally. You don't have to have, for example, Node.js installed even, that most of these linters require. And of course you don't have to install the linters themselves. And we want to have as few moving parts as possible and have a completely basic F5 experience. You open the solution, hit F5 in Visual Studio, everything runs, nothing has to install, nothing will break, nothing specific to your machine, it's just the .NET SDK that you have. We know that some teams do that, but we didn't want to go down that route.
Thank you.
Any other question? Comment?
Oh no.
Yeah, so you asked if people deploy on Azure, and I want to know more what they deploy on, how, like app service, containers, app service with containers, do they deploy GitHub Actions or not? It's not.
So
It's
it
a
is
question
for
for
you?
you to understand what people do.
Okay. Basic question: who is using Azure App Services to host their apps? Because a lot of people use Azure. Okay. Out of those people who use Azure but not app services, is it container instances also as well? For the others, what's it? It's VMs or what are the others? Because there are a lot of hands with Azure but not app services.
This slide didn't say.
Yeah, what are you using in Azure to host if it's not app services, containers, or even VMs?
I forgot what we are using essentially. Let me.
We are using functions.
Maybe. We're using functions? Functions. Yeah.
That was a trick
This was
question.
meant to be as Azure, yeah. You may use functions, but probably not for hosting or for apps.
I forgot. I don't remember.
Anyway, the others, on-premises, anybody?
Not anymore, sadly.
That's great.
.NET?
AWS?
.NET?
AWS. .NET is on Azure App Services.
Yeah, but maybe they use .NET.
Okay. .NET.
Benedict,
Somebody should.
just Benedict.
Yeah. In .NET you can have CI as well, by the way. I didn't talk about that because that's very .NET specific, but there you can also have automated deployments of themes to your .NET site, which is again as SaaS, those are tenants. You are not deploying C# code, but just the front end. I think we covered that, Sebastian. Or are you interested in some user stats still? Okay.
Thanks, Jonathan. So you mentioned you're using GitHub Actions and you first deploy on stage slot and then swap the slots. So to swap the slots, do you use automated process like GitHub Action to swap the stage to production, or is it something you log into the portal and then swap the production stage?
That would be enough as well, just using the swap button in the Azure portal. But it's actually automated. So here is the one I've shown last. Oh, yeah. This is a workflow that runs on a click. You can actually change the triggers for all of these. We like to have that manual that, okay, I want to swap out to production now. But this could be triggered based on tags as well or commit. So this is automated. This at the core pretty much pushes that button. But apart from that, it also there's a quick ping to the staging slot to make sure that it actually runs. So this is again a very rudimentary smoke test. Then it does the swap. It also tests the production slot. Again, very rudimentary test. And then there are these two other things, actually three because I forgot to mention one. There are these two other things which are special. One is adding a tag in the Git repository that it's called production/latest, by the way. That tells you that this is the commit that's currently running in production. And it's also a production/ and then a timestamp to say that, okay, this is when we swap that out to production at this time. Secondly, there is this release annotations, which is, as mentioned, application insights. The observability platform of Azure supports that. It adds markers to the charts pretty much. And there's a third thing it does that I forgot to mention. It creates a release on GitHub. So even for these projects, we have releases. Again, with all of this, the point is that we should be very clear what went on to production and when, what does it contain, who worked on it. And of course, we are a very open source company, so doing things similar to managing open source projects, even for private projects like this, is kind of natural.
Yeah, thank you.
Okay, then thank you, Zoltán, and
All right, thank you very much again.
we will have a break now.